It's the beginning of July. The hottest day of the year so far was about a week ago. It saw 500,000 people descending on beaches in Bournemouth. It's more of a typical British summertime at the moment. Camping weather, I call it, after many a long year under canvas listening to the soft patter of cold rain. There's lots of talk at the moment about global warming and climate change and a call to action. Recently, the government declared a climate emergency. We had the spectacle of Extinction Rebellion gluing themselves to tube trains. What I'd like to do today is to take a look at the science behind the headlines. Once we've done that, maybe then we can go save the world. Let's start off with some questions from last time. The greenhouse effect. 1. What are the two most common greenhouse gases? 2. Can you name any other greenhouse gases? 3. Briefly describe how the greenhouse effect works. 4. What is the effect of the greenhouse effect? Really badly worded question there. Pause the film, see if you've got some answers to those. The two most common greenhouse gases are carbon dioxide and water vapour. Others include methane, ozone, nitrous oxides and chlorofluorocarbons. Chlorofluorocarbons used to be used in aerosols and also in fridges, but their use was banned some time ago. Greenhouse gases absorb long-wave radiation that is emitted by the surface of the Earth, trapping some of the energy beneath it, rather like the glass in a greenhouse. The greenhouse effect keeps the Earth warmer than if it didn't have an atmosphere. Climate is not the same as weather. Weather is the state of the atmosphere at a given time and place. It is measured in terms of factors such as temperature, rainfall, humidity, and cloudiness. Climate is the average weather for a region over a long period of time, usually 30 years. Weather can change several times a day. The climate normally takes a long time to change. Systematic recording of weather data has only occurred since the 19th century. These and other records have shown that the climate does naturally change over time. For example, paintings and diaries provide information about the Little Ice Age. This was a period of cooling from about 1300 to 1850. Many glaciers increased in size, crops were lost, and major rivers such as the Thames regularly froze. Before the Little Ice Age, there was an unusually warm period known as the Medieval Warm Period, which lasted for about 8 centuries. And then there were particular years. 1816 was particularly cold, as was the extreme weather events of 535 AD. Global warming. This is a graph produced by NASA showing the temperature change in the last 50 years. It compares the years 1951 to 1978 with 2010 to 2019. The highest temperature change we can see is in the Arctic, shown in red, with temperature changes of more than 4 degrees centigrade. This country shows a temperature increase of around 2 degrees centigrade. Compare that to 1816, the year without a summer. It was about 0.4 to 0.7 degrees centigrade. What is global warming? Global warming is the ongoing rise of the average temperature of the Earth's climate system. It is a major aspect of climate change which, in addition to rising global surface temperature, also includes its effects, such as changes in rainfall. While there have been prehistoric periods of global warming, observed changes since the mid-20th century have been unprecedented in the rate and scale. What causes global warming? Burning fossil fuels and man's activities produces carbon dioxide and other greenhouse gases. These go into the atmosphere. Short-wave radiation from the sun passes through them, but long-wave radiation directed back up from the Earth's surface does not. They absorb the radiation and re-emit it in all directions. This is the greenhouse effect. We looked at this last time. The more greenhouse gases there are, the less radiation is emitted from the atmosphere into space. This will increase the global temperatures. Should we be worried about global warming? Higher temperatures cause seawater to expand and ice to melt, causing sea levels to rise. It has risen a little bit over the last 100 years. If it keeps rising, it will be bad news for people and animals living in low-lying places. It will lead to flooding, resulting in the loss of habitats. The distribution of many wild animals and plant species may change as temperatures increase, and the amount of rainfall changes in different areas. Some species may become more widely distributed. For example, a species that needs warmer temperatures may spread further as the conditions they thrive in exist over a wider area. Other species may become less widely distributed. For example, species that need cooler temperatures may have smaller ranges as the conditions they thrive in exist over a smaller area. There could be changes in migration patterns. Some birds may migrate further north as more northern areas are getting warmer. Biodiversity could be reduced if some species are unable to survive a change in the climate, so become extinct. How hot can the greenhouse effect get? Well, the planet Venus is further from the Sun than Mercury, but has a higher average temperature. Its surface can reach up to 482 degrees centigrade, which is hot enough to melt lead. Venus's atmosphere is mostly made up of carbon dioxide, which traps so much of the solar radiation that the planet becomes extremely hot. The hostile climate conditions on Venus make it impossible for life to survive. Well, what about global dimming? At the same time that we have global warming due to an increase of greenhouse gases in the air, we also have global dimming due to pollution in the atmosphere. We know this. If we didn't, we have the Indian Ocean brown cloud covering parts of South Asia to remind us. Not as much solar radiation reaches the Earth. Despite this, the Earth is still warming up. This means the effects of global warming are worse than we think. Following 9/11, when commercial aeroplanes were grounded, scientists studied the effects of global dimming and were able to observe the opposite phenomenon, or global brightening. Let me give you another example. more recent. People in the northern Indian state of Punjab are reacting with awe at the sight of the Himalayan mountain range, which is now visible from more than 100 miles away due to the reduction in air pollution caused by the country's coronavirus lockdown. Indians in the city of Jalandhar and the surrounding area have posted photos online of the views from their homes, with some saying they haven't seen the peaks of the Himalayas for decades. I think you can see from those pictures global dimming and global brightening. What is climate change? Climate change is a natural phenomenon and normally takes place over several centuries. The term climate change is being used now to refer to the current climate. This is because recent scientific records show that the global climate seems to be warming up more rapidly than usual. For example, 18 of the last 19 years have been the warmest in recorded history. So what happens when fossil fuels are burned? Fossil fuels are carbon-based materials that formed over millions of years from the remains of ancient plants and animals. Fossil fuels are burned to generate heat. In power stations, in cars, this combustion creates carbon dioxide and water as waste products. Greater use of fossil fuels is thought to be the main source of the increase in atmospheric carbon dioxide. Carbon dioxide is considered the most significant greenhouse gas. This is because carbon dioxide can remain in the environment over a long time, from 50 to 200 years. Any process producing carbon dioxide today could affect the climate for hundreds of years. Carbon is present in all living things and moves through the environment in a chain of reactions called the carbon cycle. So what else affects greenhouse gas levels? Burning wood releases carbon dioxide into the atmosphere. Living trees also have a major impact on the atmosphere as they produce oxygen and absorb the greenhouse gas carbon dioxide. Deforestation reduces the amount of photosynthesis taking place and so increases carbon dioxide levels. Rice farming and cattle farming produce the greenhouse gas methane. This gas is 7.5 times more effective as a greenhouse gas than carbon dioxide, but is currently in the atmosphere at much lower levels. Atmospheric carbon dioxide levels are measured around the world to detect global trends in this greenhouse gas. The standard measurement used is parts per million. The global average atmospheric carbon dioxide in 2018 was 407.4 parts per million. Carbon dioxide levels today are higher than at any point in at least the past 800,000 years. Research stations for monitoring atmospheric gases are usually sited in remote places. This one is in Hawaii. Ice cores are long columns of ice that are drilled out of glaciers. Ice cores are studied to increase understanding of the history of climate as they provide data about the distant past. Air bubbles trapped in the ice are used to estimate carbon dioxide levels thousands of years ago. This is called a proxy record. These are indirect climate measures of the climate that have not been recorded using instruments. Tree rings are another type of proxy record. This is data collected from the Greenland ice sheet. If you look at the graph at the bottom on the right, you can see temperature increases. Data collected by climate scientists can be used to answer two key questions. Is the climate really changing rapidly? And is human activity causing this climate change? These graphs show how carbon dioxide concentrations have changed over time. Around 200 years ago, carbon dioxide levels were about 280 parts per million, and now about 407 parts per million. I think that was in 2018. The global average temperature has increased at the same time as the levels of carbon dioxide have risen. So if you compare those two graphs, you can see that as the rate of carbon dioxide has increased, the temperature has increased. We say that there appears to be a positive relationship between carbon dioxide levels and temperature. It could be that the carbon dioxide levels have increased because the temperature has increased, or the temperature has increased because the carbon dioxide levels have increased. You need to be very careful how you look at data. Scientists use experiments to explore how things work and test predictions. However, the climate is far too large and too complicated to be reproduced in a laboratory. Instead, computer models are used to represent the climate and explore the possible effects of human actions. Mathematical formulae are used to represent the separate parts of the climate system and how they interact. And nowadays they use supercomputers because climate modelling is really complex and difficult. This was the guy who first came up with it. Climate modelling evolved from a formulae used for weather prediction. These were created by Lewis Fry Richardson, an English mathematician. When his work was published in 1922, the predictions were not very accurate because the calculations took a long time. Richardson thought a hall half full of people working on the calculations would be needed to keep up with the weather. What he really needed was a supercomputer. Okay, so how accurate are our climate models? Well, there's some skepticism about the accuracy of the predictions using climate models. Climate models do not measure local variability well, and it's difficult to model some things like clouds. Cloud cover greatly influences surface temperatures. Not including clouds in models could reduce their accuracy. And to predict the contribution of humans to climate change, the models have to make assumptions about populations and economic growth. Using data from several key sources, International Panel on Climate Change, or the IPCC, have made the following projections about climate change. And I'll leave you to read those. It says we'll have an increase of 1.5 degrees. Anyway, it could be 3 degrees if we do something about it. Even assuming full implementation of conditional and unconditional nationally determined contributions submitted by the nations in the Paris Agreement, people have already pulled out of the Paris Climate Accord. It's basically saying that global warming is not going to be less than 1.5 degrees. Some effects of climate change may not take place for decades. The precautionary principle advises that a lack of scientific certainty is not an argument against taking action when there is a serious threat. This can be applied to climate change. If predictions about the human impact on climate change are correct, the results will be widespread and devastating. Rising sea levels would flood many major cities. Decreasing rainfalls in Africa could affect 70% of the continent's population, leading to widespread famine. If we delay taking action, it is likely to become impossible to avoid or reverse these climate changes. So when did it become an emergency? Maybe it became an emergency when we realised that it was a global problem that world leaders would have to work together to solve, something they've never been very good at doing. Maybe it became an emergency when people realised that they would have to rethink the lives they were living and the whole system needed to change to help them. And no one wanted to do that. Maybe it was when the young finally decided that they did care, and with their whole lives in front of them, that the future could be whatever they imagined. But it brings us to this precise point in time. And if the COVID-19 crisis has taught us anything, it is that when we need to, we can alter the way we live. And whether it's the coronavirus or the environment, there's no time quite like the present.